Hello friends, let's start off with exercise 2.2, chapter 2, relations and functions. So what's the first problem we'll see? First one, let a be equal to 1 to 3 so on up to 14. Define a relation r from a to a by r is equal to xy such that 3x minus y is equal to 0 where xy belongs to a. Write down its domain, codomain and range. So 1, 2, 3 so on up to 14, and here it is defined by the relation R from a to a is given by R is equal to set of all ordered pairs xy such that 3x minus y is equal to 0 where x comma y belongs to a. So now which is equal to, we can write this as xy set of all ordered pairs xy such that 3x is equal to y where xy belongs to a. So now we have the relation we can write down. If x is equal to 1, what are all the ordered pairs of xy? We'll see. If x is equal to 1, y is equal to 3x, no? So 3 into 1 is 3. If x is equal to 2, 3 into 2 is 6. Then if x is equal to 3, 3 into 3 is 9. Then if x is equal to 4, 3 into 4 is 12. So still here only we can take, because if we take 5, 5 3s are 15 and it doesn't, 15 is not there in A. A is only containing elements from 1 to 14. So therefore we have our ordered pairs in this R equal to 1, 3, 2, 6, 3, 9 and 4, 12. So now what is the domain of R? Is the set of all first elements of the ordered pair. So what is the domain? We'll see. Domain is nothing but the set of all first elements of A, of our relation of this R. Set of all first elements of the ordered pairs in the relation. So therefore here you have domain is equal to, or domain of R is equal to set of all 1, 2, 3, 4. So these are only the 4 elements which are there, the first elements which are there in this ordered pairs in the relation. Now what is this codomain? Codomain is nothing but it is the whole set A is the codomain of the relation R. If you want to see what is the definition of domain, codomain, you can follow the link given in the description. It's given in the concepts of all sets and relations and functions. You can go into that and see. So therefore here codomain is equal to codomain of R is equal to nothing but the set A itself. So here you are having 1, 2, 3 so on up to 14. These are all the elements or the numbers which lie in the codomain of R. And what is the range? The range of R is the set of all second elements of the ordered pairs in the relation. So therefore you have here range of R is equal to, you can see over here what is the range from this is 3, 6, 9 and 4. So you can 3, 6, 9 and 12. These are all the range of R. 3, 6, 9, 12. So this is the solution for the, what is the second problem? We'll see. Define a relation R on the set n of natural numbers by R equal to set of all xy such that y is equal to x plus 5 and x is a natural number less than 4. So natural number less than 4 is 1, 2, 3, and xy belongs to capital N, that is natural numbers. Depict the relationship using roster form. Write down the domain and the range. So now here the relation in the solution you have. What is the solution? The relation is given by relation R is given by R is equal to set of all xy such that y is equal to x plus 5. X is a natural number less than 4. Xy belongs to capital N. So now here what are all the natural numbers less than 4? So natural numbers less than 4 are 1, 2 and 3. So here you are having R is equal to, relation is nothing but 1 comma x plus 5 means 1 plus 5, that is 6. Then if x is equal to 2, y is equal to 7, and if x is equal to 3, y is equal to 8. So this is the relation which we have. So now here you know that what is the domain. Domain is all the first elements of the ordered pairs in the relation. So therefore you have domain is equal to, domain of R is equal to 1 comma 2 comma 3. And what is the range? Range is all the second elements of the ordered pairs in the relation. So therefore range of R is equal to all the second elements, that is 6, 7 and 8. So this is the range. The third problem, A is equal to 1, 2, 3, 5 and B is equal to 4, 6, 9. Define a relation R from A to B by R is equal to xy. The difference between x and y is odd. X belongs to A, y belongs to B. Write R in roster form. So what is given over here in this third problem? It is given that solution, we are given that A is equal to 1, 2, 3, 5 and B is equal to 4, 6, 9. This is given to us. So now we have to define the relation in such a way that the relation from, it is defined over here. Define a relation R. What is the definition of that relation is given. We have to write down what is it in roster form. So relation R from A to B is given as R is equal to xy such that the difference between x and y is odd, that is x belongs to A and y belongs to B. So now what are all the elements which we can get? We'll see. R is equal to, we have to take the difference in such 1 minus 4 is equal to minus 3. Then 1 minus 6 is equal to minus 5. 1 minus 9 is equal to minus 8. We cannot take that because it doesn't form an odd number. Next we take 2 comma 9 because 2 minus 4 is minus 2, 2 minus 6 is minus 4, 2 minus 9 is minus 7. It's an odd number. So therefore next we take 3, 4, then 3, 6, then we have 5 comma 4, and then we have till 5, 4 because 5 minus 9 is again Then we have 5 minus 6 is 1 here. So these all form a which we get. These are all the ordered pairs which satisfy the relation, that is the difference between x and y is odd. X belongs to A and y belongs to B. Problem. The figure shows a relationship between the sets P and Q. Write this relation in set builder form, in roster form. What is its domain and range? So you can see over here from this we can see what is the solution. We'll write down. Solution is here. What does P contain? So P is equal set of all elements 5, 6, 7, and Q contains what elements? It contains 3, 4 and 5. So we have to define this. Now what is this relationship between P and Q we have to see. So over here we can see the relation between P and Q. You can clearly see that Q is 2 less than P. So 2 less than X. So over here you can write the relation between P and Q in set builder form. That is the first one which we have in that. So R is equal to set of all x, y such that y is equal to x minus 2 for all x belongs to P, or x is equal to 5, 6, 7. So these are all the values which x take. So you can write it in this way. X belongs to P or x is equal to 5, 6, 7. So therefore this is the form in the set builder form. Now second one we have to write it in roster form. So how do we write this in roster form? Roster form we can just write down all the values. So R is equal to set of all 5, 3, then you are having 6, 4, then 7, 5. It is 2 less than the first. So what is the domain over here? Domain is equal to all the first elements, that is 5, 6, 7. And what is the range? Range is equal to 3, 4 and 5. So this is the range. What's the fifth problem? We'll see. Fifth problem is given by let A be equal to set of all 1, 2, 3, 4, 6. Let R be the relation on A defined by AB such that A comma B belongs to A. B is exactly divisible by A. So we have to write this in roster form. Find the domain of R and find the range of R. So now here what is A given to us? A is given as 1, 2, 3, 4 and 6. And what is the relation between R? That is, it's defined in what way? We can see that R is equal to set of all AB such that A comma B belongs to A and B is exactly divisible by A. We have to write all those ordered pairs. So in the roster form, how do we write? We'll see. The first one is in roster form. How do we write this? So R is equal to set of all ordered pairs where the second element is exactly divisible by the first element. So we can write it as 1, 1, 1, 2, 1, 3, 1, 4, 1, 6. Then we can write it as 2, 2. 2, 3 won't come because its second element is not divisible. You can write it as 2, 4, then 2, 6. Then next we have 3, 3, then 3, 6. 3, 4 won't be there. Then next we have 4, 4, then we have 6, 6. So these are all the ordered pairs which we have where B is exactly divisible by B. So now what is the second one? We have to write what is the domain of R. So in the domain of R you can see 1, 2, 3, 4, 6. It's A itself. And in the range part what we are seeing, we'll just see range of R is also you're having 1, 2, 3, 4 and 6. You can see over there all these elements are there as the second element. So domain R is all the first problem. Determine the domain and range of the relation R defined by set of all x comma x plus 5. X belongs to 0, 1, 2, 3, 4 and 5. So it's here clearly what is R is given to us. The relation it is given as R is equal to, it has all the ordered pairs x comma x plus 5 where x belongs to 0, 1, 2, 3, 4 and 5. So for this we have to write what is the ordered pair. We have to write what is the range, what is the relation we'll write down first, then the domain and range. So here we have, first we'll write down what is the relation. We have 0 comma 5 because if x takes 0, y will take 0 plus 5, that is 0 plus 5 is 5. Then you have 1, 6, then 2, 7, then 3, 8, then 4, 9 and 5, 10. So here you can very clearly see what is the domain of R. Domain of R is equal to set of all 0, 1, 2, 3, 4 and 5. And what is the range of R? Range of R is equal to 5, 6, 7, 8, 9 and 10. In this you can see seventh one, write the relation R is equal to x comma x cubed. X is the prime number less than 10 in roster form. So now here in the solution what do we have here is, it is given that what is the relation given to us. We are given that x comma x cubed, all the ordered pairs are in this form such that x is a prime number less than 10. So now we'll write down all the prime numbers less than 10. So the prime numbers less than 10 are 2, 3, 5 and 7. So the relation is equal to 2, 8, 3, 27 because 3 cubed is 27, 2 cubed is 8. We are writing x cubed, that is 2, 2 cubed, 3 cubed. Then you will have 4 is not there, so you have 5 cube is 125. Then you have 7 because it's a prime number, we are taking all prime numbers which are less than 10. 7 343 is 7 cube. So this is the answer. So what's the 8th problem? Let's see. Let a be equal to x, y, z and b be equal to 1, 2. Find the number of relations from a to b. So what are all the relations? We have to find out what are all the relations of this. So in order to find out, we'll write down what is the solution over here. Given to us that a be equal to x, y, z and b is equal to 1, 2. So we have to write here. Now what is a cross b? We'll see. A cross b is equal to x1, x2, y1, y2, z1, z2. So there's totally how many relations we have got? We got that cardinal number of a cross b is equal to total 6 we are having. Therefore the subsets of a cross b will be 2 to the power of 6. Thus the number of relations from a cross b is 2 to the power of 6. That is totally it is 16 into 4, that is 64 you are getting. So you can write down 2 to the power of 6 which is equal to 2 into 2 into 2 into 2 into 2 into 2. 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64 you are getting. The 9th problem, let R be the relation on Z defined by R is equal to AB such that a comma b belongs to z. A minus b is an integer. We have to find the domain and range of R. So now what is given over here? First solution in this, what is the relation R given for us? The relation R is equal to set of all a b such that a comma b belongs to z. A minus b is an integer. So now we know that the difference between any two integers is always an integer. Therefore, domain of R is equal to z, and also the range of R is equal to z. Because if you take the difference between any two integers, you are getting again an integer. So therefore, because all negative values and positive values lie in this set of integers, therefore domain of R is z, and also range of R is z. The z means integers.